So we're taking a peek at this first of our couple of final summatives here. This first one, there's a couple of ways you can tackle this. And everybody kind of has their own way of doing it. Normally what I will do, since most of your first kind of inkling when you see something in parentheses is to distribute, I'm going to go ahead and do it that way. I will show you another way you could do it, but why I'd kind of be a little frightened for some of you to try it that way. So if we went here and we said, okay, we're going to distribute first. So that would get me 3 over 2x. We're going to try to avoid the decimals here. And now some of you, when you get to this next part, you might just punch this in on the calculator. And I'll show you that in a second here. But if I was doing a little bit of side work here instead, here's what that would look like. I'd have 3/2 times negative 6 over 1. Because, again, any number can be made a fraction by putting it over 1. And so I could just multiply across and reduce it that way. Okay, that's one way that I could take care of that. The other way, of course, would be to punch it into the calculator. Now, the only issue, and we've seen this several times over the semester, the only issue that can come from punching it into the calculator is going to be, I've got to make sure I remember to put the 3/2 in parentheses. Because if I don't, I'm going to get a different answer. Okay, so I can get my -9 that way as well. So now what? Well, now my job is to work on getting that x by itself. Do not try to multiply through and get rid of the fraction yet at this point if you go this way. So we get that 9 added in. And now we get to our last step. So we get here, and again, some of you have different ways you'd go about this. This is the part where I would multiply by the reciprocal, by the flip. Because that'll take care of those. And again, if you want to go to a calculator for this, you could. Okay, 2/3 of 21 is 14. Or if you wanted, you can do 21 times 2, and then divide that answer by 3. Both of those would absolutely, positively work. So here's the other way some people will do this sometimes. I'll just kind of do it on a sticky note down here so you can kind of see, kind of pick which way you think would be better for you. Some people will see this, and they'll go, okay, I just don't want to deal with the fraction, period. So could I multiply by the reciprocal right away? And the only reason that worries me sometimes with people is they're kind of looking and they're going, all right, 12 times 2 is 24, divided by 3 is 8. You're like, shoot, that seems like a lot easier of a way. Why wouldn't people do this? Because what tends to happen is people want to do the 2/3, and for some reason they start trying to distribute, and it gets into a big bunch of craziness. As long as you can remember, hey, if I multiply by the reciprocal, it just cancels this, and then I got to do it over here too. It's a fine way of going about it. That's another way you could do it that would be absolutely fine. Let me actually put that up here. See, and that's one of the things about algebra that I think sometimes we forget, is that oftentimes there's a lot of ways of being able to tackle these that can be successful. Now, the way that was just mentioned is, could I, if I can get my pen to work here, could I multiply both sides by 2? And then go about it from there? Sure could. At this point, I could even have multiple ways. I could distribute the 3 and work it out. I could divide both sides by 3 and then just add the 6. So there's lots of good ways you could go about this one. Okay, as long as we're being algebraically sound, yeah, that's really, really Good, I think, what's that now? 1, 2, like at least 3 ways, if not 4, we could all get to the right answer. So, the one thing I will mention, though, is don't try to go into guess and check mode with this and just start plugging numbers in. Because part of the points that go with this is showing the work and letting me see that you've got that skill set. So just make sure that that gets done in there as well. Okay, so then for number 2, we're going to solve and graph the following inequalities. Show your answer in interval notation. So, okay, first thing to remember whenever we're dealing with inequalities, there's going to be 2 of them. Okay, the absolute value tells me that there will be 2. So my first one, I just copy what's already there without the absolute value bars. And then the second one, we're going to switch the arrow around. We're going to change the sign of our solution. Okay, it's got to be both. Once I do that, now I just go ahead and solve what we've got for each one. And we've talked about a couple of clues that you can have with these that make these a little bit easier when it comes to the graphing part. Now, that is my inequality solution. I've got that part. But we also talked about how the arrow can tell me a lot about what things look like. When the arrow is eating my absolute value, when it's eating the x, that's an or statement. And or statements, when we've seen these during the semester, are the ones where their graphs go out from each other. Okay, the other one, my and, which you'll see in 2b, I'll even mark that down so you've got a little hint here. Ands are the ones that come together. So if you have that little bit of a clue at the start, it should help to be able to make sure we do good things when it comes to the other things. So now, graphing we've spoke about too, the whole thing of showing your number sense with things. So here, let's see. Now, was I even good about it? I was not good about it. Well, I can't expect you to be then. So I'll get my numbers. Negative comes before positive does. So we'll make sure we get that part. And then again, I already have a little bit of a clue here. X is greater than or equal to 20. It would be a bracket. And greater than goes to the right. X is less than or equal to negative 6. And goes to the left. So that makes sense. And then interval notation goes from left to right. Well, this arrow is going forever to the left. And then it comes until it gets to this negative 6. But then there's another piece over here still. So I use my U, my union, to connect those. I start back up again at 20. Go the rest of the way. Right. And that's it. Okay. So these will kind of show me what this is supposed to look like. When I get to the and on 2b, it's going to be a very short one. It's just going to be my 2 endpoints. There won't be any infinities there. But it kind of goes back over that and lets me see how those are going to work. So not bad, not bad. Let's see what else we got here. Solve this radical equation with both methods, algebraic and graphing, to prove fluency among multiple methods. It's written so pretty. Okay, so algebraic. We're going to zoom in a little bit here. So, I have a radical that's alone by itself on this side. So we'll square both sides right away. The squared and the square root will cancel on the left. Now on the right, ooh man, we got to be careful. It's going to be really tempting to distribute the squared and call it x squared plus 9. I know it is, but that wouldn't be right. So, reminder, x minus 3 squared means that there's 2 x minus 3's. So we either have to FOIL this out, or we can box it out, depending on which route you tend to go. So I'm going to box it out just because that way I don't forget terms. We do not want to forget terms here. So as I get that in, again, we're multiplying to fill the box. So we're going to add our exponents. If we don't have more exponents, we're just kind of putting our coefficient on there and multiplying together to get what's in the boxes. So once I get that full, now I'm not multiplying anymore, I'm just combining like terms. So negative 3x and negative 3x do not cancel. Gives me negative 6x plus 9. And now my last job is to get all my terms to the x squared side, because we're probably going to have to factor or use the quadratic formula. So minus my x, I'd add my 1. Negative 6 minus 1 is negative 7x plus 10. And like I said, you've got a choice here. You can factor, or you can use the quadratic formula. So what do I know? Well, multiplies to a positive means they're both positive or both negative. Both negative. So multiply to 10, add to 7 is 5 and 2. I set each of those equal to 0. But before I go ahead and say, oh, that's the answer, and circle it and go on with my life, remember, especially when there's two answers, they both might work, but one may not. So the easiest way to do that, if we're not going to use our brain, which would be the easiest way, okay, I'm going to plug in, so I'd have the square root of 5 minus 1, which is 2, and then 5 minus 3. Okay, again, before I do anything. And if I get the same answer for both sides, that's an answer. So square root of 2 minus 1 is 1. 2 minus 3 is, negative 1. Not the same. That one doesn't work. So do double check. And the nice thing here about doing the graphing with this is that it's going to be a little bit easier for me to get that done. So, okay, the graphing part. Couple of ways you can take on the graphs. One thing you can do, because again, I'm going to graph these in different colors so you can see them a little bit easier here. X minus 3, I'm hoping you can just graph because it's a line. Negative 3 would just be put your point for your y-intercept at negative 3. And my slope would be 1 over 1. So I'd go up 1 and over 1. And I would just go crazy with the dots. As long as you can keep making dots, I would keep making them. And if you run out of room going up and right, we just do the opposite and we go down and left. I mean, shoot, I don't even really need to connect the dots. I can see from there that you've got that in there. Now, when it comes to this, you can either do your parent points and shift, because we'd have a shift of right 1, or you can go to y equals, pull up a chart, and use some of those coordinate points. I'm going to try and get it where I don't get total. So let's see, we've got 1, 0, and 2, 1. else have we got here? Because we'd be just looking for whole numbers if we were doing this. So we got 5, 2, 10, 3. 5, 2, 10, 3. And what I'd be looking for, of course, when we're trying to solve it graphing, is where's the point they have in common. And there it is right there. What is that? That's when the x value equals 5. So algebraically and graphically doing the same thing. And even if you were more comfortable, you even could graph, and I'll show you that as well. We could graph the x minus 3 on here too. And then if you looked at the chart, and we talked about this before, you could go down until you found the place where the y values were the same in both, and then the x value is just going to be your solution. You'd still need to graph the lines, but you'd have the points to use, and you could do it that way too. So lots of options, lots of availability for us. And so that'd be the same thing for 3b. So we're going to move to 4a next. Okay, solve by using square roots. First job, get my x term by itself. So once we've got that, still don't square root yet. We need x squared alone before we do that. So divide by 2. Now we're ready to do our square root. Now we've got several things we're going to have to keep in mind this time. Okay, whenever we do the square root, the squared here tells me there's 2 answers. So that's plus minus. Now if I go to my calculator and try to type in the square root of, no, not point, negative 25, error, non-real answer. What do I have to do to deal with the negative? Think gross. You have to pull an I out. Okay? The I out coming out takes care of the negative. And then if I can break down the radical, and I certainly can this time, it's a perfect square, then I have to do that. So since the square root of 25 is 5, my answer would be plus or minus 5i. If you wrote I5, that'd be okay too. But I do have to remember to get the I out of there. Okay, so anytime we get a negative underneath, we're just pulling out an I. And that'd be the same thing on 4b as well. 5. Given the function f of x equals square root of x, create a function g of x that shifts the original function left 4 units and down 9 units. Okay? So here's basically what that's saying. When we're doing these, okay, remember, this is what these look like to begin with. This is my left and right shift. This is my up, down. So what they want you to do is you create the equation that creates these shifts. So you're like, okay. So left 4 would be plus, and under the radical, because that's where my left and right is. And down 9, which would be outside the radical. That's it. Okay, there's no other math to do. It's just plug the numbers in, get them in the right spot. You're good. So that hopefully wouldn't be too bad either. You're like, okay. The next one, ooh. The school that Jenna goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for $38. The school took in $52 on the second day by selling 3 senior citizens tickets and 2 child tickets. Define what your 2 variables represent, then set up a system. Do not solve. So since we're being pushed to use X and Y here, you can kind of determine the way you want to work it either way. So here, now here's where some of you may go a little too general. Let's say you write that as your answer. Okay, senior citizen tickets. Okay, well, is that telling me the number? No, because I already know how many I sold. I don't know how much they cost, though. And that's the thing that I need to know. Price or a dollar sign or something needs to get in there with it. And then the price of a children's ticket would be this one, because that's what I'm actually trying to find out. So then trying to set up a system, I just kind of take it sentence by sentence. On the first day, we sold 3 senior citizen tickets and 1 child ticket for and 1 child ticket for $38. And then the second day, we took in $52 by selling 3 senior citizen and 2 child tickets. That's all. So I'm feeling pretty good that most of you would be okay here. I just want to make sure we're not getting ourselves caught here by not getting, the cost in there somehow. You could say cost, you could put the dollar sign, you could put the price, they'd all work. Okay, and then 6b again would be similar. So as we flip, okay, state the domain and range, tell whether it's a function. Okay, domain. X values, left to right. Be watching. Is it arrows or is it dots? If it's arrows, we get infinity. If it's dots, we're just looking, okay, I'm thinking about it furthest left and furthest right for X's point of view. So from -8 to +3. Range is my Y values from bottom to top. It's the same well, not the same 2 points. Bottom point, looking at it from Y. Top point, looking at it from Y. And there's nothing wrong with actually drawing in like I'm doing here. But again, bottom, -4, to top, 5. And then is it a function? Does it pass the vertical line test? And remember, that is just when you take, piece of paper, a pencil, something, and just go along in your function, and as long as you're only crossing one spot for each one, that would be yes. But just to say, for instance, on 7b, you might notice, right here, it crosses at 2 spots, here and here. So that one would be no. But it's just kind of getting you thinking about that a bit. But it's got to be the vertical line. Okay, we're not doing the horizontal, just the vertical. Get to 8 here. Maya's going to shoot an arrow upward. The height is given by this equation. Complete the table to show the heights at the given times. Okay, we're going to keep this part simple. We're going to get out of our... Move this up a bit. Okay, so basically we're going to type our equation in, or you even could just plug those values in for t up here. So we get those in, and we're going to look at the chart. And whatever values are in the chart are what we're going to plug in here. So 279, 307, 303. And again, I could get the same thing by plugging those into here if I didn't want to mess with the chart. So we did that. And then find the average rate of change in height from 3 to 4, okay? Rate of change is just a fancy way of saying slope. So when we're doing that part, we're doing it in feet per second. So what I'm going to do is I'm going to take my feet for 4 and my feet for 3. Because again, when you're doing slope, remember it's y minus y, x minus x. Well, my feet are kind of my y here. And my seconds, so here I did 4 and then 3, so I'll do the same down here. And then I just let the calculator help me out with the rest. 307 minus 279 is 28. 4 minus 3 is 1. So my rate of change would be 28 feet per second. Okay, biggest thing there is I just got to remember I'm subtracting the values. And just think about it too, you talk in feet per second, you would talk about seconds per feet. That really wouldn't make much sense. So that's the easy way to remember where everything goes as far as that goes. Okay, with my slopes. That. Next part, we're going to graph the absolute value function, identify the vertex, and transformations. Again, it's a fancy way of saying shifts. My vertex, opposite of h, plus k. So opposite of what's inside, keep what's out. Negative 3, 2. Transformations. Just like it was with the radicals that we were doing before, this is my left, right. So left 3. And this is my up, down, and it stays the way that it's supposed to. And I also would notice if I did my vertex first, if you start at 0, where did you go? You went left 3 and up 2. Okay, so they connect. But I do have to graph this still. Remember, my air quote slope would just be 1. So from there I can go up and over 1. I just do it in both directions. Because these make V shapes. And I'm good. And it'd be the same way on 9B. Not going to be mean and put a different air quote slope in there. Just going to have it be 1, just so we can remember that. Then we get to go way back. This is like first 2 weeks. Rewrite the equation solving for A. Oh my goodness, there's A's everywhere. Can I just divide both sides by by M and be done? No. Why? Because I have A's in 2 places. I have to get them together first. So since this side already has an A term, we'll minus the 5A over here. So I've got AM minus 5A equals 4. I've got to get this down to 1A before I can solve for it. Well, how are you going to do that? Well, if I look at these 2 terms, what do they have in common? They both have A. So if I factor out the A times what gets me AM, M. A times what gets me negative 5A, negative 5. And all of a sudden, I'm down to 1A. So once I get there, if I want to solve for A, and I'm multiplying it by this other term, so A is going to equal 4 over M minus 5. So all A's together, factor out what they have in common, and then divide by what's left. On 11a and no, you're not going to have like 5 of these in a row like you do here on these. So we'll kind of roll through these. Couple things to remember, and we've spoken about this quite a bit. Here, I would suggest always dealing with the negative exponents first. That's the only part I would deal with. So everything that is not a negative exponent, I leave alone. Negative exponents get flipped. Because then, I'll see here 10 over 12 reduce, 5 over 6, okay. There's no other y terms, so they're going to stay there. And here, when we're multiplying with exponents, we add them. So 3 plus 9 is 12. No other, like, variables to deal with. That's as far as I can go. And that may be all we can do sometimes, is something just like that. Here, same idea. Deal with the negative exponents first. Okay, the 3 doesn't flip. It doesn't have a negative exponent. So I try to reduce 5 over 3. It's still 5 over 3. That's y and that's x. I can't put them together. That's all I can do. Ooh, negative 1 on the outside. Okay, now what's that mean? That means that negative 1 is going to go to the 7, the y to the 4th, the 2, and the x to the 5th. Holy moly. So we're multiplying negative 1 times each of those exponents. And now you look at it and you're like, wow, everything's negative. So everything's going to flip? Yep. But once I do that, 2 over 7 doesn't reduce. X and y are different variables. That's all I can do. So as we kind of roll towards the end of these, you're like, ooh, 1/2, yuck. Okay, remember, something to the 1/2 is the same as taking the square root of it. So if that's true, the square root of 25 is 5. 8 times 1/2, half of 8 is 4. The square root of 49 is 7. And half of 10 is 5. No negative exponents. I can't put x and y together. That one's just done. And we're okay there. And then the last one here, let's see if I can squeeze this in. I don't see any negative exponents. That's always nice. So that'd be 1 over 10. Now, when we're dividing, we're subtracting. So 8 minus 7 is 1. Bigger exponents on top. So that's where my answer would go. As far as my y's go, 6 minus 2 is 4. Bigger exponents at the bottom. And that's where my answer goes. No more negative exponents, anything like that, so I'm good. But again, that's why there's several of these on here. Get some extra practice. Get feeling pretty good. So we can have those as we move forward. We're almost there. Factor. Okay, just diamonds. Nothing bad. Check your signs. My multiply number is negative, which means there's 1 of each. Middle number is negative, which means the bigger number is going to be negative. So 2 numbers that multiply to 30, but that are 7 apart. So if you start kind of dividing in here, 7. What's that? There is going to be a specific help sheet or something. Let me pause this for a second so I don't go into gibbering. So here, I get my 10 and 3. There is no equals 0, so I just am factoring it, and that's done. So get them factored, get them set. Okay, completing the square. Now with these, and this one was chosen because this is probably the easiest one to deal with. I put a blank with my y's. I put a blank with my x's. And the concept is going to be the same as it always has been. I take my b, divide it by 2, and I square it. And that's what's going to go in my blank. And there's going to be 2 quick steps left to finish this guy off. My first job is to get it into the square of a binomial. And we've said before that all that is, it's taking half of my b, either that or if I did my side work, I can use that. And then the only thing left is to get y by itself. And we're good. Okay, so blank with y, blank with x. Half b, square half b. Add it here, add it there. And then finally, what's the center and radius of the circle? Okay, a little more with our completing the square things. We're going to put a blank with our x's. We're going to put a blank with our y's. We're going to put those same blanks with our value on the other side. And then we just do our little side work here. Have b and square it. My y's, same thing. Have b and square it. Your squared will always come out positive. X, positive 4. Y, negative 3. But here it doesn't just say get into form. It says, what is the center and the radius? My center is opposite of H and opposite of K. And my radius would be the square root of my right side. Okay, that basically is your post. And I'll answer that other question once I have the answer to it. So tomorrow